Hello friends, welcome to my channel. Today we'll be discussing LeetCode 669 Trim a Binary Search Tree problem. It's a medium level problem and it is given in LeetCode daily challenge. First we will read the problem. Given the root of the binary search tree and the lowest and the highest boundaries as low and high, trim the tree so that all the elements lies in the range low to high. Trimming the tree should not change the relative structure of the elements, means the relative structure of the element should not change. Okay, and it is given that it will always it will exist a unique answer. Okay, let's see the first example. The first example given here is the first example given here is 0 1 2, and we can see that the low limit is given 1 and the high limit is given 2, and we can see that the this value exists in the low comma high interval, so it will be included, and it also lies in the interval 1 to 2, but the value 0 does not lies in the interval 1 to 2, so it will not be included and it will be disconnected from the tree, and we will either return the left value or the right value depending upon the tree. So we can see that here only 1 and 2 are existing. Okay, now let's walk through the second example. We can see that in the second example the tree here is 3 is the root node, and the interval given here is 1 2 3, and the 3 lies in the interval, so it is good to go. Now we will search in the left part. We can see that the 0 does not and after this we will traverse in the right part and then in the left part. After reaching here we will compare if one lies in the interval 1 to 3. Yes, the one lies in the interval 1 to 3, so we'll return back here. And on returning back here we will compare now the value 2. The 2 lies in the interval 1 to 3. Yes, the value lies in the interval 1 to 3, so we'll return back here. And after that we will compare the value 0. The value 0 here does not lies in the interval 1 to 3, so we will return either the left child or the right child of the node 0 which would be existing. We can see here that the left child is not existing and it is null, so it will not be returned, and we can see that here the right child is existing, so this value will be removed and the 2 here points to 3. Now it will go to the right subtree where we can check that the 4 does not lies in the interval 1 to 3, so it will return either the left child or the right child because both the children are null, so this value will be removed from this, and the tree will be 3 to 1 as given. So now let's walk through to the code. We can see that first we will make a function trim which takes the parameter root and low, the interval and the high. Okay, we will make the name of the function as trim. Now declaring the function, it will be returning a tree node pointer and trim int low and int high where the interval will be existing. Okay, and now we will see if we will compare if root is null. If the root is not existing, then we will return the null, else we will first traverse on the left subtree. We will be traversing the left subtree. We will name this node as L node. Okay, you can name this as any convention. It's not compulsory that you should name as L node, and then we will pass root to left and interval low to high, and after that we will comparing if the root dot left is equal to L node. If this case exists, then if this case doesn't exist, then we will point the root left to the L node. Okay, because if we will see that here's the 0 is not included and it will be including the right subtree, so 3 will be pointing to the 2 1 here. Okay, then same goes on with the right subtree. We can see that tree node, right tree node, we can name as our node, and it's trim root right and low and high interval which will be passing. And if we will see that if root dot right is not equal to our node, then we will be assigning the root dot right to the our node. Okay, and now after that we will be checking if the value of the root is greater than the high value, or the value of the root is less than the low value, then we would be assigning the left child or the right child which would be existing, means which would be not null. So root dot left, which is the left child. If it is existing, means if it is not null, then we will return root dot left. We are using ternary operator. And if it is not existing, then we will return root dot right. Okay, and after that we will return root, because it is a it has returned out tree node. Let's run the code. It says accepted, runtime 0 seconds. Question here is accepted. Thank you friends for being patient in watching the video. I hope you like the solution. Please comment if you have any doubt. Thank you friends.